Good morning, everyone. Welcome to today's lecture on artificial intelligence planning. In this session, we are going to understand how an intelligent system decides what actions to perform and in what sequence to achieve the desired goal. So, just like humans plan before performing any task, AI system also needs planning to make intelligent decisions. So, throughout this lecture, we will learn what planning is, how a planning agent works, the famous Blackwell problem, and finally, an important problem solving strategy called mean end analysis. Before we begin, let's look at learning objective. By the end of the session, we should be able to understand what planning means in artificial intelligence, and then identify the components of simple planning agents, and then explain the Blackwell problem, which is one of the most widely used example in AI planning. Finally, the last thing is understand mean end analysis, what it is and how it helps to solve the complex problem. Let's start with the introduction, what planning actually means. Planning in artificial intelligence is a process of generating a sequence of action that allows an intelligent agent to move from an initial state to goal state. Instead of acting randomly, which means instead of acting randomly, an AI system first thinks about what should be done, when it should be done, and in which order it should be done. Let me explain this with a simple example. Imagine you are planning a trip from Chennai to Bangalore. So before you are leaving, you naturally will ask yourself several questions, right? Like say for example, should I travel by car or train or flight? Which route will take less time? Where should I stop for food? How much fuel will I need if I go by car? So all these decisions are made before you even start your journey, right? So this entire process is called planning. Similarly, AI system also analyze different possibilities before taking any action. For example, Google Maps. Google Maps doesn't simply tell you one route. It compares several routes based on traffic, distance, tolls and travel time before recommending the best route to you, right? So this is an example of AI planning in our everyday life. So now we'll see the components of planning problem. Every planning problem consists of three important components. The first will be the states, second one will be action, the last one is goal. So a state which represents the current situation or the condition of the environment. For example, if a robot is standing at the entrance of a room, a robot is standing at the entrance of a room, then it is a current state actually. For an agent, it is a current state. The second component is action, which is also called as an operator. Actions are all the possible operation that agent can perform. For example, move forward, turn left, pick up an object or place an object. So these are all the actions or operations the agent can perform. So every action has two important properties. One is called precondition, other one is called effect. The precondition must be true. Actually, what does precondition mean? The precondition which must be true before an action can be executed. The second is called as effect, right? The second property is called effect. The effect describes how environment changes after the action is performed. So these are all the properties of operators or this action. Okay. Finally, we have the goal. That is a third component. The goal represents a desired final state that the agent wants to achieve. So every planning problem starts from the current states, performs a sequence of valid action and finally reaches the goal state. Okay, next slide. Now let's understand what a simple planning agent is. A planning agent is an intelligent system that thinks before it acts. Actually, what does it mean means, instead of reacting immediately, it first observes the environment, determines its goal, generates a suitable plan and then executes the plan. Do you able to understand? Let me take an example. Think of a delivery robot inside a hospital. Okay, suppose it needs to deliver a medicine to room number 305. So it doesn't start moving randomly, right? First it identifies its current location, then it determines the destination. Destination is here room number 305. Then it calculates the best possible route. Finally it starts moving according to the planned sequence, right? So this is a way a simple planning agent will be operating on it. This ability to think ahead, before reacting, it thinks ahead, right, makes a planning agent much more efficient than a simple reactive system. Okay, now we're going to see how the planning agent works step by step. Okay, the first step of a planning agent is perceive. So what does perceive mean? The agent gathers the information from its surrounding using sensors or input data. Do you able to understand what perceive is? Is nothing but it gathers the information from its surrounding using a sensor, mostly by using a sensor or by input data. Okay, the second step is define the goal. The agent clearly understand what needs to be achieved. Okay, the goal will be very accurate. What need to be achieved, the agent will have a clear idea on that. And then third step is planning. Here the agent generates a sequence of action using planning algorithm or search techniques. Finally comes execution. The planned actions are carried out one after another until the goal is achieved. Do you able to understand? The planned actions are carried out one after another until the goal is achieved. So this complete cycle, like a perceive, defining the goal, plan, execute, this complete cycle enables a AI system to solve problem intelligently. Now we will move to the Blackwell problem, which is the most famous example used to explain AI planning. Okay, imagine we have three blocks named A, B, C placed on a table. Our objective is to rearrange these blocks into a desired configuration. So now we are not looking into the problem statement here. What will be the initial position or what position it should be changed. So we are not. Generally, what does a Blackwell problem mean? To rearrange these blocks into a desired configuration. So initially all three blocks are placed separately on the table. Our goal may be to place, say for example, these are all examples. Say for our goal may be to place the block A on top of block B and block B on top of block C. So to achieve this arrangement, the AI system must determine the correct sequence of action, right? So it cannot place a block A directly on block B if block B is not already positioned correctly. Understood? It cannot place a block A directly on a block B if block B is not already positioned correctly. Therefore, the agent carefully plans each movement. The Blackwell problem is widely used because it demonstrates how AI searches for the best sequence of actions rather than making a random moves. So let's move to the next slide. Now we have focusing on main elements of Blackwell problem. First element is we have object which include, what are the objects we have in this problem? Which includes the blocks and the table, right? The next is states. States. A state describes the current arrangement of all the blocks. So initially what we have told, all the blocks are on the table only. Then the next element would be we have actions. The common action is move, where a block is moved from one position to another. So let me explain this problem with a pictorial image. So before that we are seeing a theoretical explanation. Okay, so before moving a block, certain preconditions must be satisfied. For example, the block must be free, meaning no other block is placed on top of it. Before moving a block, some preconditions has to be definitely has to be satisfied. That is, one of the preconditions is a block must be free, which means no other block is placed on top of it. Similarly, the destination block should be also be clear. Destination block means which is the correct, the order, the last block which also must be the clear. Once the move is completed, the arrangement changes. Even if you are moving a single action has been done, the whole arrangement has been changed, right? So these changes are called the effects of the action. Finally, the AI continuously checks the AI will, I mean, artificial intelligence continuously checks these conditions until it reaches the required goal. Okay, it might be the theoretical explanation definitely will be somewhat not relatable to you, but anyhow, in the next slide we will see with a pictorial representation. Okay, now let us see the illustration of Blackwell problem using an image. I have tried to bring the whole problem in a single slide. So first thing we will understand what the Blackwell problem is. What does it consist of? So it consists of number of blocks, one. Second thing is a robotic arm can perform actions on the block, right? And then blocks can be either on the table or on another top of the another block, I mean on top of another block, right? So this is the environment or the perception of the Blackwell problem will be. What does it has, what are the components, I mean what are the object it has, everything we were able to see. So let's move to the element. The element is we are having is 4: object, initial state, goal state, and operator. So objects we have seen, it has blocks, it has table, and robotic arm. In robotic arm, I didn't include this robotic arm in my previous slide, so we can include here. And then initial state. So as we are taking a problem statement, this will be my initial state, that is ABC. All 3 blocks were on the table, and my goal state will be like this: ABC, that is A is stacked upon B and B has to be stacked upon C. Able to get it? So these are the initial state and my goal state. Operator is nothing but what are the actions that we can perform to reach the goal state. So what are the actions? Pick up of X, put down of X, stack X comma Y, unstack X comma Y. So pick up and put down you can able to understand by the name itself, but stack mean here we have 2 parameters X comma Y, that is stack X, I mean put block X on top of Y. Unstack means similarly, I mean remove block X from the top of Y. So here in order to achieve our goal state from the initial state, so here we are processing. So initially what we are doing, unstacking the B from the table, which means pick up B from the table. Okay, and after that we are stacking the B on C. Before that we have to check the precondition whether the C is on free, already free or not. We have to check it, right? So okay, so it is free. And finally now we are unstacking A from the table. That means the next step would be we have to stack the A on B. So in each and every step, while in the third step, after the completion of third step, we will be checking the arrangement whether we have any point reached our goal state or not. So each and every step is being checked for the goal state. So finally in the 5th step we have achieved our goal state. That is what goal state is. In the 6th step we are declaring that goal state is achieved. Actually what is the point here is the goal is to transform the initial state to goal state using a sequence of action, right? So here what is the process we are doing, mean we are from the initial state to goal state, we are by a sequence of action we are reaching to the goal state, right? But many different sequence may exist here. So the algorithm searches for an effective one, efficient one. So this problem helps in understanding planning, search space, and state representation. So what is the plan here means unstack B comma table means what does it mean? So unstacking we have block B from the table and we are stacking the block B on top of C, and again we are unstacking the A from the table and we are stacking the B on, stacking the A on top of the B. So this is how we are reaching the goal state. So in the single problem we were able to understand how the planning of an AI system works, and how the search space is happening. Why we need to do the search space, many possibilities to reach the goal will be it's there, but we need the efficient effective one, right? So the efficient one we need. So search space is there, and the state representation is also we were able to achieve in the Blackwell problem. Okay, in the next slide let's study an important problem solving strategy called means ends analysis, commonly abbreviated as MEA. The main idea behind MEA is very simple. It compares the current state. Actually, it compares the current state with the goal state and identifies the difference between them. Then it selects an action that can reduce the difference. Do you able to follow up? It compares the current state, that is initial state, with the goal state and identifies the difference between them. Then it selects an action that can reduce which can reduce the difference. This process continuously repeated until the goal is achieved. Rather than solving the entire, which means actually in other way we can tell, rather than solving the entire problem at once, this MEA divides it into a smaller and more manageable sub problems. This makes the complex planning much easier. Okay, now let's see the steps of means and analysis. Actually, means and analysis follows a systematic process. First thing, it will identify the difference between the current states and the goal states. Goal state. Second thing, it chooses an operator or action that can reduce this difference. Third one, it verifies whether all preconditions required for that actions are satisfied or not. If not, those preconditions become a new sub goals. Do you understand? So first thing, it will check for the difference between the current state and the goal state. Second thing, it chooses an action which can reduce this difference. Third thing, it verifies whether all the preconditions required to perform this action are satisfied or not. If that is not, the precondition is not satisfied, mean those preconditions becomes a new sub goal. Next, solve these sub goals. Next step will be it will solve these sub goals one by one. Once the conditions are met, perform the selected action. So this cycle continues until the final goal is successfully achieved. In simple word, we can say MEA, that is means ends analysis, solves a big problem by continuously solving a smaller problem. Now let's understand means end analysis using a real life problem. Suppose you want to visit your friend's house across the city. So your current state will be you are at your home. Okay, you are in your location, that is in your home. So your goal state will be you need to reach your friend's home. Okay, so your initial status, you are at your home, that is at home, your home, and your goal state has to be you have to reach the friend's house, right? So the difference between the initial and the goal state will be is your location here. So one possible means is to drive your car. So in order to distance is there here from your initial to goal location. Initial location is there, goal location is there. So difference will be the distance is the only difference. Okay, actually we consider initial stages. Initial state is your location. So in order to reach, say for example 30 kilometers apart from far away your friend is there, your friend's home is there. Okay, so that 30 kilometer, how we can reduce it? So one of the possible means is to either you can take your car or you can hire a taxi, or you can take you can go by you can reach your friend's house by getting any government vehicle like through bus or train, electric train, anything. Okay, so we'll take one example. One possible mean is to drive your car. So however, before driving we need a certain precondition must be satisfied, right? So what is the thing is, here we are not taking the precondition that you must have a car. So we are directly moving, you have a car. Okay, we are assuming you are having a car. Your car should have enough fuel. First precondition is that any the petrol is there or not. You should have the car keys. Okay, and then you should be inside the car. You should be able to drive the car. So we can create many sub-problems. You should have a driving license. So these are all can be created as a preconditions. So these becomes a smaller sub-goal. Suppose you're having car, you are having keys, you are having the enough fuel, but you don't have driving license. How we can allow you to drive, right? So first sub-goal will become you have to take the license. So in order to take a license, you should go for the driving classes. So such thing. So once these sub goals are completed, you can drive to your friend's house. This is how exactly the means ends analysis works in artificial intelligence. I hope all have understood the concept which we have seen today. So in order to summarize, what we have learned means the concept of AI planning, understood the components of a planning problem, and explored how the simple planning agent works, and then studied about the Blackwell problem, and finally we discussed means ends analysis as a powerful problem solving strategy. So in the next video we will continue with the remaining concepts of unit 5. Thank you and happy learning.